Hello, my name is Jeffries, and this is my video submission for Quiz 2. And today I don't have very much time, so I have a lot of the work already done out here, as you can see. But for part 3, I do have a decent amount of explaining to do for my logic behind how I got there. But first I do want to mention that all of my numbers that are bolded are multiplied by 4 due to my last number, my PID, being 4. And I'm going to get straight into part 1. Part 1 simply asks for the speed up that is achieved using MIPS FP. I wrote the speed up equation here, which is 1 over 1 minus the fraction enhanced plus the fraction enhanced divided by improvement factor. This gives me this right here, where I have 1 divided by 1 minus 0.2 due to this is the fraction enhanced plus 0.2 once again divided by the float point execution factor up here, which is 2 times 4. That gives me 1.212 for my speed up, and that's the first answer. For part 2, I'm looking for the percentage of the unenhanced system execution time that would be executed by MIPS FP. I wasn't too sure how to go about this, so I went with a very basic approach. I took the time that it would take for the MIPS FP on its own to execute a instruction. So that's 0.2 divided by 8, and that equals 0.02. And I put that over the execution time that it would take to execute an instruction in total, right? Which is where this comes from. It's basically just this. I just put 0.025 at the top instead of 1. And that gave me a 3.03% approximately, because this is a repeating number. Alright, and this leads me to my very last problem, problem 3, where I will be explaining. Because I use mostly reasoning to solve this problem, due to there not being a lot of information out there, I use one of the examples and kind of makeshifted an answer that made sense. So here I set the performance benefit to x because we don't know what the performance benefit is. And I know, but what I do know is that MIPS Night chips do sell for $20. So I put the performance, the unknown performance, over the $20 price, and I essentially do the same thing for MIPS FP, except for I multiply it by the speed up, due to the fact that, the MIPS FP processor has a speed up of 1.212. That is the whole point of the first problem. Now, from there, however, I need a maximum price, which is why I have y here. And in order for me to find a maximum price, I need to do a comparison here. So I set MIPS FP greater than MIPS Nice by itself, due to the fact that when you bring over y, you want y to be less than whatever number you finish with, because we're looking for the maximum. In simple math here, I multiply both sides by the reciprocal and of the right side, and then I multiply both sides by y. That way I get my x's on both sides, and I end up with this is greater than y, right? And the x's cancel out here. This is a multiply, which leaves me with y is less than 1.212 times 20, which gives me $24.24 as my final answer.